In this series of videos, we'll talk about the design patterns. And in this particular video, I'll talk about the overview of solid principles. Typically, my content will have three parts: why, what, and how. The why part deals with why do we even need this particular concept. The what part is what exactly is the concept, and in how part we'll see how we are going to achieve it or apply it. Now, coming to the why part, why does this solid design principle exist? It is because we want to write maintainable, flexible, and scalable code. We'll see this with an example. Um, Let me create a class here. For example, we have a class like accounts class. Suppose it has four private members. Now it has four private members, and suppose we have a constructor also. Let me create a constructor here. Okay, and now look, let's suppose I have uh, this method like accounts save to db here itself. So we have save to database, verify phone number, send notification, all three methods here itself. Now if you see, this particular class accounts is doing too many things. So basically it is responsible to saving itself to database. It is also responsible to verify whether phone number is correct or not, and again it's responsible for sending notification. So see, it has too many responsibilities here. Let's talk about the flexibility, scalability part and maintainability part. So it is not maintainable. The account class handles multiple responsibility: managing account data, then saving it to database, then validating phone numbers. All these things are happening within the same class. If you basically need to change any database logic, any phone number logic, or even if you want to have to send notification, it is basically getting inside a particular class and then changing everything within one class. It's not maintainable. So suppose in future if some bug comes here, then it would be very hard for you to find that which particular logic is causing that particular bug. Now let's talk about flexibility. Now suppose you want to verify phone number differently, like format check, country specific validation, or anything else. The current class design forces you to modify it directly, increasing the chance of introducing bugs. It doesn't allow easy extension by adding new functionality without changing the existing code. Let's talk about scalability. So suppose we have send notification here and we are sending currently notification via email. And now if we want to send notification using text messages or WhatsApp messages, so we have to edit this send notification method itself, and it is not at all scalable. As a new feature like email verification, account notification, or reports are added, this class will become bloated with many unrelated methods. The tightly coupled responsibility caused the class to grow and become complex, making it difficult to manage larger projects. In short, to improve maintainability, flexibility, and scalability, each responsibilities should be separated in a different distinct classes. Now coming to what. So what SOLID means in software design. SOLID is an acronym for five important principles introduced by Robert C. Martin. Now these principles help us write code that is easier to maintain, flexible to change, and scalable as the project grows. What are the five principles that we have? First one is single responsibility principle. That means that a particular class should have single responsibility only. And we are going to discuss all these things in our next upcoming videos. Open close principle, again, open for extension, close for modification. Liskov substitution principle. This means that any subclass should be able to replace its parent class without breaking the program. So the derived classes need to behave like their base classes. We'll talk about this. Now integration segregation principle. In integration segregation principle, instead of having one big interface, it's better to have several small interfaces. Classes should implement the methods they actually need. Now coming to dependency inversion principle, like it states that high level modules should not depend directly on low level modules. So I understand that currently you might not be able to grasp everything, but in upcoming videos, I'll explain each of these principles in detail. Thank you guys.